Problem number 11 from section 4.5. A person invests $4,000 in stocks today, and their value doubles every 6 years. Let f of t be the value in dollars of the investment t years from now. Find the equation of f, and then once you've done that, find the value of the investment 20 years from now. Well, don't forget, whenever we're looking for an exponential function, it's f of x equals a times b to the x, where a is either the y-intercept or the initial value. Well, the initial value that we begin with is $4,000, so that will be the a. Now, all we have to find next is the base multiplier. Well, every 6 years, the value doubles, so therefore the base multiplier would be 2. However, we can't just put it to the t, because that would mean after 1 year it would double. So we have to divide that by 6. Now notice when I put a 6 in, then I would have t being 6 over 6, which is 1, and it would double then. So there's the equation that you could use to calculate part B. I'll show you in a minute how to write that to the t. But first, let's go ahead and answer part B. Find the value of the investment 20 years from now. Well, that's just finding f of t. Notice we can come up with a reasonable idea. In other words, it's 4,000 now. After 6 years, it'll be double, or 8,000. After 12 years, it will be double, or 16,000. And after 18 years, it would double again, which would make it 32,000. So we have to get an answer over 32,000. That way we have a ballpark figure. So let's get our calculator out. We're just going to enter the 4,000 times 2 raised to the power of 20 divided by 6. Again, it's good to know if it makes sense. We come up with $40,317.47. So that would be the value after that many years. I also want you to be able to write this equation in the form of some base raised to the t. Again, let's go ahead and do that. Let's move this up a bit. So, an extension of a would be if I had f of t equals 4,000. I want to find the value in which 2 will be raised to the t. So notice that this is the same equation as this, because the properties of exponents tell us we multiply these together, which is t over 6. So therefore, to find the base multiplier for each year rather than every 6 years, all we have to do is find 2 to the 1/6. So I'll pull the calculator over, find 2 raised to the 1/6, and we get 1.122. 1.122. Now, if you were to use this equation on the f of 20, you would get a different answer because we did round it, and so it excludes some of the decimals. So if you use this equation, that's why you got a little different answer than that one there. So there's problem 11.